Let's see question number 19, and that has been derived from the topic ray optics for a convex lens here. So very much related to lens formula, and a certain element of velocity has been added. An object is at a distance of 20 meter from a convex lens of focal length 0.3 meter. So well, the object is between 2f and infinity. Okay, so the lens forms an image of the object. So that's fine. In this situation, the image is going to be real, inverted, and diminished. That's very straightforward thing. The object now moves away from the lens at a speed of 5 meter per second. The speed and direction of the image, that's what we need to calculate. So the situation of calculation comes something like this. What we'll see is that here is the lens, and this is the principal axis of the lens. Okay, so of course 2f is somewhere here, and the object is here, and the object is at 20 meter at this instant, and it's moving away from the lens at a speed of 5 meter per second. So it's moving away from the lens at a speed of 5 meter per second. Now we need to calculate the speed of the image at this situation. Fine, what I'll do is that 1 by v minus 1 by u is 1 by f, and minus 1 by v square dv by dt plus 1 by u square du by dt is equal to 0, focal length being constant. Now it's all done. Just one more additional step you need to do, that for this given instant, when the object distance is at 20 meter, you need to calculate the image distance. Okay, you can do that by putting here u as minus 20, f as plus 0.3, and du by dt, the object speed that has been given as 5 meter per second. So you do all this calculation, this unknown part dv by dt will match with option number 3, and that stands out to be the correct option for question number 19. Fine then, now it's time to move to question number 20. And question number 20 is another question that has been brought from rotational motion. One we've already seen, and this one is a straightforward. It says a slab is subjected to two forces F1 and F2 of the same magnitude. So let me show it here. So here is the situation. One is F1, another is F2. So this given slab is being subjected to two forces, and notice it says of same magnitude. Force F2 vector is an xy plane. Fine. So just an additional clarification. This F2, which is in the xy plane, let's better write it, okay? So I can write F2 vector as, if you just resolve F2, you see, F sine 30, so that would be in negative x-axis. So that's going to be minus f by 2 I cap. F cos 30 is going to be in this direction. So that's minus root 3 f by 2 j cap. So that's straightforward. We calculated the value of F2. Then F1x along z-axis. All right, so F1 can be so easily be written as, f of k cap as per the given direction. And F1 acts at the point 2i cap plus 3j cap. So it makes sense that F1 is acting at the mid, 2i cap plus 3j cap. So that can be written as R1, which is 2i cap plus 3j cap. And we need to calculate the moment of these forces about point O. Okay, R1 incidentally is being measured from the origin. And what about R2? Well, that's not a big surprise. R2 is going to be 6 j cap, because this distance is 6 along y-axis. Now I have, R1, I have F1, R2, F2. So I need to calculate the moment of force or the torque of these forces about O. So that's straightforward. R1 cross F1 plus R2 cross F2. And when you do that, you are going to get your answer matched with option number 1. So option number 1 is the correct one for this. It's now time we move to the next question. Question number 21, that has been taken from the topic electromagnetic waves. And notice, electromagnetic wave is the topic which is excluded from JEE Advanced syllabus and is specifically present only in JEE Main syllabus. So those are the areas where you really need to focus if you are an aspirant of JEE Mains. Now see, it says that in an electromagnetic wave, there is the intensity of 50 watt per meter square, enters from a medium to another medium, and yes, initially it's in vacuum, you may say, and yes, the refractive index of the next medium is n. We need to calculate the ratio of magnitude of the electric field before and after entering into the medium. So the set, you can see the first one is the ratio of electric field before and after entering the medium. The second one is the ratio of magnetic field before and after entering the medium. Now, a way is that you go through the basic, but this question is so wonderfully framed that, just by a small mathematical manipulation, you can easily calculate it. You see how? It's something like this. The refractive index, we know, is C by V. And here you could write n equals to E naught by B naught, because velocity of electromagnetic wave is the ratio of electric field to magnetic field. So here, E naught represents the electric field before entering the medium, and E represents the electric field after entering the medium. So here you get N equals to E naught divided by E and B divided by B naught. This is how it goes. And now just see, you just need to have the ratio of E naught by E and B naught by B. And out of all this set of data, you see, if the first one represents the ratio of electric field, the second one represents the ratio of magnetic field, that too, before entering and after entering, it's so obvious that option number 2 has to be the correct one. So question number 21 has option number 2 as the correct option. All right, now let's move to question number 22.